safe. All right. Hold on a second now. Hold on a second. Let me just something. Give me a second, guys. Starting in a move. Not sure. Everything set up right. Okay. All right. Morning, everybody. That's it. This paper for you to do. So you know what I'm gonna say. If you didn't do it, you need to do it, even after I do it. Want to get success in the subject, you have to put pen to paper. Not about watching somebody else work out solutions. If that alone was good enough, people wouldn't have to practice. Get me? Because there's enough. There is far more than enough of persons doing solutions on video for you to watch. All right, everybody online. Can you hear me again and see the screen again?
Yes, sir.
All right, so we have some data, internet issues a while ago. So I think we're back up on that. So I'm basically using the hotspot, so shouldn't have a problem after this. All right. Use this thing. I'm just trying to set up so that once we start, I don't have to stop finding problems again. All right, so I think we're good to go now. Let's check one more thing. Yeah, we're good to go now. All right, guys. So this is the 2015 exam paper. It's a June 2015 exam paper, paper 2. And let's just get cracking. Start at number 1. So I bring up the calculator because usually number 1 is a calculator question. All right, use a calculator, calculate some fractions and stuff. So let's see. And there you go. It says using a calculator or otherwise, you have to calculate the exact value of this thing. So again, it's typing this thing in the calculator. Make sure you type it the right way. So let's go. So this we're putting it up here. So I'm going to do a mixed number of 2 and 2/5. I'm going to minus another mixed number, 1 1/3. Make sure you type it in exactly as it is there. Then we're adding 3 1/2, mixed number again, 3 1/2. And it's giving me 4.56 repeated. All right, so to get as a fraction, this is the answer right here. This one, 131, or we can maybe write this one as an exact value. All right, 2 and 2/5 minus 1 1/3 plus 3 1/2. Okay, equals, I'm going to write 137 over 30. Or I'm going to write 4 and 17 over 30. Over 30. And that's that. All right, nice and easy. Next one is supposed to calculate this. Same thing, put it in the calculator. So let's go back and clear the calculator. There's a bracket, 4.14 divided by 5.75 close bracket plus 1.62, and we're squaring that. And we're getting 3.3444. Give it exact because the question said exact. All right, that's that. Next question is first to do this. All of them exact. Let's make sure now. Exact. All of them exact. So many of them they give this time. This one. Everything is multiplying now. So it's 2 times 3.142. That's pi times 1.25. Look at it. Make sure it's the same thing we have there. Yes, it is. Equals 7.855. Easy as that. Next question. This one, calculate again. So make sure the calculator is in degrees. Look up there for the DEG, because you're going to be doing trigs. Make sure the calculator is in degrees. It is. And that's going to be the square root of 2.89. That's the answer now, because the tan of 45 is 1. So that's going to be the answer, 1.7. But I can show you still. Tan of 45. Tan of 45 degrees. So you get the same answer. But the tan of 45 degrees is 1. That's 1.7. That's the answer, 1.7. All right. That's that, 1.7 is the answer. So far, so good. A lot of free marks so far. All right, so much free marks that. This is 3 on this page and 3 on this page. See, 6 marks for doing some simple thing like that in an exam. Can you believe? Man. All right, so let's do some real maths with this one now. So this question says, the table below shows a shopping bill prepared for Mrs. Rowe. It says the price of some items are missing. So let's look at it carefully now. So these are the items. These are the quantity of the items: 3 kilograms, 4 kilograms, 2 kilograms. This is the unit cost, the cost for one, and this is the total that you're gonna get. So basically, you are multiplying this by this. Let's set up this. Let's set up that times multiply yes by this figure equals this figure. That's how it goes. All right. That's how it goes for all the values. So in the first case, to calculate the value of x, it's going to be 3 times the x equals 10.80. So we can set that up. 3 times the x. But x is in dollars, and we know it's in dollars, and it's cost in dollars. Just like this one is in dollars. So we can say 3 times the x value equals 10.80. Then to get the x, we divide on the 3. So the x is 10.80 divided by 3. Remember, it's money. And so you have to put it as money when you finish. It's 10.8 divided by 3. That's $3.60. Put the dollar sign on it and write 3.60. Because it's money, you put on the additional 0 there. So if you notice, this is in money format. So you have to put these, the x and the y, also in money format. All right, that's what you have to observe. Next part wants us to say, all right, next part says, if the cost price of 1 kilogram of rice is 80 cents more than 1 kilogram of flour, all right, so the rice is 80 cents more. 80 cents more than the flour. This is the cost for the flour right here, you know, right here. This is the flour. And this is 80 cents more than this. All right? It says calculate the value of y and z. So first, the y is going to be the cost of the flour, which is $1, 1.60 plus 80 cents. 80 cents. 80 cents is $0.80. That's what we're doing. That becomes $2.40. Again, if you have $2.40, $2.40. That is the y value. But to go to that, you also want the z value. So let me shift this over. 1.6 plus 0.8. 1.6 plus 0.8 is 2.4. $2.40. Then you want the z value, in which now this 4 times the y is equal to the z. All right, so you can say the z is equal to the 4 times the y. Let's set up like that. All right, so the z is now equal to 4 times y, and the y is this value I put in here. So the z becomes 4 times $2.40. Put the dollar sign there. And so we're working out the z like that. 4 times $2.40. $9.60. $9.60. That is it. But okay with that? Very good. Easy question. Easy question. Shopping bill. Anything else? It says then, a tax of 10% of the total cost price, of the 3 items is added to Mrs. Rose's bill. What is Mrs. Rose's total bill? So if she's adding a tax of 10%, it means that she's paying 110%. You don't have to calculate 10% first. She's paying 110% of the total. What is our total bill? Our total bill is the sum of these 3. All right, so I'm going to put in that the z is $9.60 right here. I'm going to put it on the table. So this is really $9.60. It's $9.60. And our total bill before tax is the sum of these 3 values, which we're going to work out over here. So it's 10.8 plus 9.6 plus 3.2. That's $23.60. That is $23.60 is the total. You're free to put this on the exam paper. So the amount that she's paying is 110% of that, because she's paying 10% more than this. Some person will calculate 10% first and then add it. You don't need to do that. You're paying 10% more, they're paying 110%. So the total bill is 110% of this. All right, so that is it. So she pays total bill. All right, so total bill equals 110% of that total up here, 2360. And I'm leaving this on the paper for the examiner to see where the 2360 came from. All right, so it's 110%, which is same as 1.1. Again, 110%, there's a percent on this again. Times, marker, yes. 110% times 23.6. So that's 25.96. It's 25.96. Trying to give him a hand today. All right, what I go to that? Let's give this teacher a marker. Give me a second. Give me a second, guys. Okay, guys, sorry about that. All right, but online with me still? Online? Yes. All right, yes, good. All right, I don't think we need a calculator for the next question. So let's continue here now. So this one says, given that A equals 4, B equals 2, and C equals -1, we have to find this value. So have to be careful with these negative signs, for example, right? That's what we have to do. We have to be careful with negative signs. So we're going to work this out with these values. So this then becomes equal to, the A is 4 minus, that's this minus, the B is just 2, and then we're adding a -1. You're adding a -1. So the plus or -1 is same as just subtracting a 1. So this is the same as 4 minus 2 minus 1. So the answer here is just 1. Because 4 minus 3. So the answer there is just 1. All right. This one now. This becomes equal to 2 times the A. The A is 4. The A is 4. And you're raising 4 to the power B. And the B is 2. The B is 2. You have to work out this first. Square that first. You can't go multiplying the 2 times the 4. Because the 4 is under the square. In the Badman system, you have to work out powers first. Right? I usually tell the students P Badmas, in other words, the powers first. So work out the squared first, and then you would get 2 times 16. As a 4 squared is 16. Then 2 times 16 is 32. Some people do not take the chances of putting it in the calculator. Get it right answer. Look, if you multiply the 2 times 4, you're going to get 8 squared, which is wrong. Right? You cannot go and put the 2 on the 4 because the 2, you have to do the power first. The 4 is under the square, so you have to do that for first. I'll put it another way. This 4 squared is the same as saying 2 times 4 times 4. could break out this squared and write it as 4 times 4 like that. Get me? And then multiply straight across. 2 times 4 is 8, 8 4 is 32. So we could do it that, like that as well. So let me put this as an OR right here. So we could say OR. You could put it like that and still get 32. It to be 8 times 4. You could multiply straight across. All right, that is that. 1 mark for that. Nice and easy. Next question says, a bottle contains 500 milliliters of orange juice. A bottle contains 500 milliliters of orange juice. Write an expression for each of the following. The amount of juice left, after pouring out P milliliters. So if you have 500 there, you pour out P, the amount left is going to be 500 subtract P milliliters. That's the amount left. Since I said expression, I'm just going to put something like this. Let's write, let's put a statement. Let's say amount left is this. And I'm putting on my symbol, my unit. Next part. Q glasses, you pour out Q glasses. Q is the number of glasses that you pour out. Each containing R milliliters. So if you pour out Q glasses, each containing R milliliters, then the total amount you pour out is Q times R. You have poured out Q times R. So the amount left in this case is the 500 that you had minus Q times R. That's how I write R. Don't pay it no mind. That's how I write it. Q times R milliliters. But good at that? But okay? Good. Let's continue.
Sure.
Yes?
For the first one, when they mix up the something, they call it the P for something else. When they think say they have to come up with the next value for the amount pour out.
Well, no, you understand the mistake. No, you understand the mistake. Whatever you said is wrong. This is the answer.
Is there any other right there that alone you can put?
This is all this. There's no other answer. That's it. 500 minus P. If you have 500 of something and you pour out P, you have 500 minus P left. The question asks how much do you have left? You don't know P. You don't have a value for P. Right? You don't have a value for P. So if you have 500 something and you take away P from it, you're gonna have 500 minus P left, whatever P is. All right, that is it. All right, cool. You go to that explanation, you okay?
Yes, sir. Yes, sir.
All right, good. Next one. Write this as a single fraction. Some people go and do this thing. I will 3 times 5 is 15, and say 3 divided by 15 is 5. 5 times that. 5 into 15 is 3. 3 times that. But I don't like that. That is like rote learning. I don't like that approach. You do it that way and get the right answer, no problem. But I feel like when people do it that way, they don't really understand what they're doing. So when you're adding fractions, you want them to be related. You want them to have the same denominator. So this denominator and this denominator, you want to bring them to the same common denominator. So normally it's the lowest common multiple. It's 15. So to get this denominator to be 50, multiply by 5. So you multiply under here by 5, you also have to multiply the numerator by 5. And this one, to make this denominator become 15, you have to multiply by 3. So multiply under here by 3, you also have to multiply up here by 3. So I'm going to work this out, which is going to give me 5 times the 2k is 10k over the 5 times 3 is 15. This plus, then I'm doing 3 times these two values now. So it's 3 times the 2 first is 6, and 3 times the minus k, negative 3k, all of that over 15. Know that they have the same denominator, they are related. It means now that you can finish this off by putting that common denominator of 15 and you're adding the numerator values and take good care with the signs, the negative sign, for example. All right, so in this case, it is 10k plus a negative 3k. So like 10 minus 3 is 7. I'm going to write that. I'm getting 7k. And then it is nothing, no number over here, plus 6. So you're going to get plus 6. And that's his answer. Done right there. All right. 7k plus 6. All right. Next question. This question says 4 mangoes and 2 pears cost $24. So 4 is the number of mangoes, 2 is the number of pears, cost $24. While 2 mangoes and 3 pears cost $16. Write an equation, write a pair of simultaneous equation in X and Y to represent this given information. So if I call X the number of mangoes, no, not X, the 4 is the number, I want the cost of a mango. So X is going to be the cost of a mango. So it's going to be 4X plus 2 pears, 2Y. I'm making X be the number, the cost for a mango, Y be the cost for a pear. That equals $24. That's the first equation. And then over this side, we have a different color for this side. The other information. 2 mangoes, that is 2 times the cost of a mango, and plus 3 pears, 3 times the cost of a pear. That equals $16. Those are my 2 equations. So from word to equation. All right, that's as simple as that. Write it down. So it's 4X plus 2Y equals 24, and 2X plus 3Y equals 16. All right, so those are the 2 equations. The question says, state clearly what X and Y represent. So X represent cost of 1 mango. Cost of 1 mango. What Y represent? Cost of 1 pear. Cost of 1 is pear. Just pear, right? Yeah, pear. Cost of 1 pear. Are you okay with that? Are you good?
Yes, sir. They just put on mango and pear. Never did notice they have put on price.
No. You have put on it cost is the cost. You have 4 is the number of mangoes. So 4 mangoes and 2 pears cost $25. Right? Then X has to be the cost of a mango. 4 times the cost of 1 mango plus 2 times the cost of a pear totals $24. Right? You can't just put on mangoes. X represent the cost of the mangoes. They are telling you the number of mangoes. They are telling you the number of pears. And they give it total law as money, dollars. So the X has to represent the cost of 1 mango, and it's 4 of them you have. And the Y must represent, in the first equation, the Y must represent the cost of pear. All right, learn from mistakes. Mr. Ellis, all right? Good. Next one says now, what do I have to do next? All right, I thought they would have asked us to solve them. They're not asking us to solve them. So that is it. That's the answer for that one. All right, those 2 equations. Next one says, factorize completely this thing. All right. First thing I see is the common factor of A. So when I factorize the A first, I'm going to get A squared minus 12. But this one kind of tricky, you know, because a lot of persons would stop there. But this can be factorized again. So even though this is not a squared number, it can be made into a squared number by square rooting it and then squaring it back. I kind of feel like if you wrote this alone, CSEC would give you a marks. But you see, because that's a completely, I'm going to show that to be factorized further. So I could write this as A times A squared minus 12. I'm going to square root the 12 and then square it back. Then it's now like I have the difference of 2 squares. Remember now, say if you write this, they'll give it the marks. But you can go further if you write the 12 as a squared number. So you square root it and then square it back. Then it's like we set up the difference of 2 squares inside here. What the rule for the difference of 2 squares go? Let's write it over here. It says x squared minus y squared will be equal to x minus y times x plus y. I'm shift this over a bit. Running out of space. And then shift this over. Let's write the rule. So it's x minus y times x plus y, right? X minus y times x plus y. So I'm using this rule now right here inside the bracket. So then it would then become, first factor is a, and then this now the difference of 2 squares would be a minus the square root of 12 times a plus the square root of 12. I really don't expect them to expect that as an answer. So I would say for this question, especially like was 1 mark, if you write this as the answer, I'll give it to you today. I don't know that they expect you to know this part, to know to that part. All right? But that is it. If this was a number like 9, for example, instead of 12 right here, this was, for example, 9. They would know that the 9 is 3 squared. They know that this will be 3, x minus 3, x plus 3. If this was a 9, if this right here was a 9 instead, I know the squared numbers, right? 12 is not a perfect squared number, so I have to square root it and then square it back. That's what it is as a squared number. All right, but that is it. So let me leave what the correct thing. I just feel like if you wrote this, they'll give it a marks. But this is actually the correct factorization for the last all the way down. All right, let's continue. Then we have this perfect, this quadratic. My n values are prime. I like that. My n values are prime. So I know the factors of this 2x squared can only be 2x and x. The factors of this 3 can only be 1 and 3. Those are the only numbers I'm working with. 2x and x, 1 and 3. So it must easy to factorize. Then this plus out here tells me that the 2 signs in the bracket are the same. They are both negative. In addition to that, because this is a plus, it's the sum of the far product and the near product that gives you the middle term. The sum. And the difference, the sum. Factorizing it in 1 line. You have to practice this way. It's 2 marks for it. You don't need to do the lengthy process when this is easy. So factorize it quick and fast. All the factors of the 2x squared is 2x and x. All the factors of this 3 is 1 and 3. So I put the 1 and the 3 there, or you put the 3 over here and the 1 over here. That's the correct position of them. Because I know that the far product and the near product must add. One was add because the last term is positive. They must add to give me the middle value. The far product is 2x and the near product is 3x. 2x and 3x add to 5. If I put the values, if I put the 1 and the 3 the other way around, look what to that. Put the 1 here and the 3 here. Then this time this will be 6x, and this time this will be 1x, sorry. 6x and 1x is 7x, but your middle term is 5. You get me? So they couldn't work that way, in that order. All right, so I want to go watch over the video, listen back what I'm saying, and try it. You have to learn to do it this way. So the 1 needs to go here and 3 goes here. 2 sides of the bracket are the same, they are both negative. Negative. That's the answer now. So check it, the far product again. Know what the signs are there will be negative 2x, and the near product will be negative 3x. The negative 3x and the negative 2x, they add to negative 5x. So you know that it is correct. You have to learn to do it this way, guys. Save time, practice. When the n values are prime like these are, it becomes easy to do. All right, let's continue. That's the answer. Next question. Sets. This question says, the Venn diagram below shows the number of students who play guitar G or violin V in a class of 40 students. First thing I'm going to do is put 40 right here. Because I don't want to forget. Putting 40 right here. It means that here, 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 and here must all add up to 40. That's what it means. All the subsets must add up to 40. Total in the Venn diagram is 40. Right? It says, how many play neither guitar nor violin? This out here play neither. 12. All right? 12. So the answer for this one is 12. Next one. Write an expression in terms of x which represent the total number in the class. So basically adding up these for the total number in the class. And I only want an expression. Just write the expression. So it was something like, don't put no equal anywhere in there for them to think it's an equation. Total is 2x, that's this 2x, plus x, plus x, that's this x, plus 4, that's this 4, plus 12. I can simplify it. This is 3x, and I can say, i.e., that is 3x plus 16. So this is 3x, and this 112 is 16. That's it. I want to say this equals 40. The total must be 40. And so now write an equation now which may be used to determine the number of students in the class. The equation now is that this equals 40. 3x plus 16 is now equal to 40. How many students play guitar? Let's look at it. Guitar is this 3x right here. So you really want to calculate 3x. 2x plus x play guitar. Look here. I'm now in our class and up on the phone, I'm running outside. Put away the phones. Pay attention. Alright, so I really want to calculate 3x. Who play guitar? 2x plus x. So you want to calculate the value of 3x, making it easy for you. So from this equation, we can calculate 3x by just subtracting the 16. So I'm going to play guitar, I'm going to write that is 3x right here. This is 3x, which is equal to 40 minus 16. What is that? What is that? What? 24, that's the answer. So in this case, you don't have to calculate x first because it's 3x play guitar. You don't have to calculate x first. But understand that? In the classroom online, but understand that?
Yes, sir.
All right. Good. You don't need to calculate x. Touch Mr. Williams over there for me. Touch him for me. Touch with him. The mother online, she said, must wake up. All right, let's continue. You never see her when a champs, he's sleeping. This question says, using a ruler, pencil, and pair of compasses, construct a triangle ABC. AB must be 9, angle ABC must be 90 degrees, and angle at BC must be 6. So I want to sketch it and then construct it. Sketch it and then construct it. So I'm going to put AB right here. And the angle at B must be 90. So we need a 90 right here, so the B, 90 degrees. And then the BC up here, so must be 6. So this must be 9 centimeters, and this must be 6 centimeters. And that's going to be a triangle, ABC. That's what we're constructing, right? The things I wanted to do with it, it's a measure and state the angle BAC. On the diagram, put point D such that ABC is a parallelogram. All right. So let me show you what I'm going to do now. So the angle that I want to measure, angle BAC, that's this angle. I want to measure. Then I want a parallelogram ABCD. ABCD. So I have A, B, and C already, So D must be somewhere out here. Hold on, let me say. I want a parallelogram. On the diagram, show a point D such that ABCD is a parallelogram. I guess it's any point. Show the point D such that ABCD is a parallelogram. So D has to be A, B, C, D. It's going to end up being like a rectangle. You know? You can put D anywhere on this line. Anywhere on this line, D can go. All right, so it's actually a rectangle you're going to get. So it happens to be a 90-degree angle that they gave us right here. Let's make sure. It says AB must be 9 down here. Angle ABC, which means that the angle is at B must be 90. BC must be 6. That's it. All right, let's construct it now. Just making sure because I said they said the parallelogram instead of rectangle, they said parallelogram. So let's go. All right. So first I'm going to use my ruler and draw my 9-centimeter line. Let's draw it in black. From 0 up to 9. Let's see that way today. Let's see we can use a ruler. So that's it. And then I'm going to construct the 90. The compass. Let's change the color of the pen. I'm going to construct the 90 over here as I have in the sketch. All right. So to construct 90 degrees, my method is to construct 120. It's 260 degrees and then bisect the second 60. All right. So I'm rotating all the way over there. And I move the pointer here. And then I make an arc there. And then you move the point up here. Rotate down. And you make another arc there. What you have now is a 120-degree arc. The second arc makes 120, 60 plus 60. All right. So I'm going to bisect the second 60 up here. This is second 60 arc up the top right here. I'm going to bisect, put the point here, rotate over, make an arc at the top. Then I'm going to move the point here, rotate over here, and make an arc there. And that's that. I need a 6-centimeter line through this now. Let me draw the line first and then mark off 6 centimeters on it. So I'm just gonna draw a line through that intersection first. Let's go back for the black. Draw a line through that intersection. So I'm starting at this point. Once I draw a line through this intersection here, through here, that's a 90 degree. To the point at the end and the intersection at the top, that's 90 degree. All right. That's my line. I'm going to bring back the ruler. I can measure the 6 centimeters on it, but I can do it this way as well. You put it on the ruler at 0. And you hold it out to 6. Then you lock it. Let me change the color to blue. And then come here and measure the 6 centimeters. And across there, that's 6 centimeters. That intersection. And then I go back for my ruler, go for my black, and complete the triangle. This end to right there. That's it. And that I can label it up now. So this is A, this is B, up here is C. All right. So to do the bar, let me show you can do the parallelogram now. I can use the compass and make the parallelogram now. All right. So I have this distance of 6. This distance is 6. I know that this distance is already 6 right here. Where you go? This distance is 6. What I can do, I can leave the compass at that distance at 6. Come over to the other end, but this compass not moved. Make an arc. It's a different color. It's a different color. Let's use green for this part of it. Make an arc. That is 6, you know. Then now I'm going to come back down on this line and open the compass, make it 9 to the and transfer the length of this line out here. Make this line now 9. Lock the compass. I need to transfer this 9 up here. I want to put the point here. Rotate the compass around. That's 9, you know. And then I'm going to cross it. That intersection is 9. So this length across here so is 9. Same like down here, so 9. That's our parallelogram. So now draw a straight line through there now. Go back for the black. And draw a straight line through from this point or wrong thing I use. Wrong thing I use. Draw a straight line from this to here. That's 9. And draw a straight line from this intersection at A up to that intersection there. That's 6. So that's a parallelogram. It's a rectangle. I'm going to mark right here. I don't want to press the undo button because sometimes when I press the undo button, it clears everything. So that little squiggly line right here, let's ignore it for the time being for me, please. This squiggly line. Let's ignore it for me. It's not a part of it, that little line. Let's ignore it for me, please. But how I found my parallelogram is transfer the length, right, from opposite sides using the compass by making arcs of the same length. But that is it. They wanted us to measure this angle. So let's bring in the protractor to do it. Right here, they wanted us to measure this angle. Hold on a second. Oh, this I don't want. So let's come here and measure it. So the baseline is already 2, 0. You can see it. And I'm measuring the 0 scale and the inner scale from the 0 up. That looks like about 34 degrees. See that? I'm measuring right here. Look, I'm measuring right here. Measure up to here. Measure up to right here. That's about the inner scale I've used doing, the inner one. So that looks like about 34 degrees. 34 degrees. Don't quite reach 35. 34 degrees. So right here is 34 degrees. That's the answer for this one, 34 degrees. And then I will do with this construction. So we can see the ABC, the wheel is a rectangle. But that is it. I don't have an erase button on this app. I could erase some of those marks. That is it. All right, let's go. We don't do this topic yet, so I'm not spending plenty of time on it to actually do the topic. All right, good. Going good. Number 4. That's a quadratic. It's a smile shape quadratic. Remember the value is going to be symmetrical about the axis of symmetry. All right. So I see a 5 here and I see a 5 here. So it means that whatever value, you see, the value that's between the -3 and the 5 is the same between here and here. So basically, I can tell you that whatever value you get for here is the same value for here. Same value. All right. But we have to fill it out. We're going to have to work it out. Well, let's read the question. It says the table below is designed to show the x and y values for the function, this quadratic function. All right, for integer values of x from -2 to 4. That's these integer values of x. All right. It says complete the table for the function. So you need to read this value and this value. So we're going to take this -1 and drop it inside here for the x and for the x there as well. All right, so let me just show the calculation. So for this one, it basically would be -1 squared minus 2 times -1 minus 3. That will be the y value. But I put the -1 in this function right here. here and there. That's what I'm gonna get. All right, so what is that? No, so this -1 squared is actually 1. This minus is a plus, so you get +2, and then -3, so you're gonna get 0. So right here is 0. So these are the roots, 0. That's gonna be 0 as well, but let's prove it. If I put the 3 in there now, put the 3 in the same function. So this one, this value would be 3 squared minus 2 times 3 minus 3. 3 squared is 9. This is -6 and -3. So it becomes 0 as well. So this is actually 0. So this is actually 0. So it will equals 0. So those are the roots. All right. So now that I know the roots, well, these are the roots. These are the points on the roots on the x-axis. So these are the roots. So I want to know the minimum point is on one of these values. So the average roots, remember the xt value, x value turning point is the average of the roots. So if I do the -1 plus 3 divided by the 2 to get my xt value, x value at the turning point, xt, x value at the turning point is the average of the roots. It's going to be equal to 1. So it means that this is my axis of symmetry. So it means that if this is my axis of symmetry, that's my x value at the turning point, that's my minimum point. So this represents my minimum point. 1, -4. So I don't have a calculator to find the mean, but it's given in the table. All right, so we're going to need to draw the graph, which is what this part is telling us to do now. It says on the graph on page 13, plot the graph of that function using a scale of 2 centimeters to represent 1 unit. All right, so I think I have another copy of this thing that we can bring up and use over here. Where are you? This is it. All right, so let's find the graph. So I don't want us to put it on this graph. All right, so let me just put it there. All right, so what are the points? First, we need a scale. The scale is 2 centimeters to 1 unit on the x-axis, 1 centimeter to 1 unit on the y-axis. And we're going from -2 to 4. Start going from -2 to 4, and we're going up by what? 2 centimeters, right? On the x-axis. So if I put -2 out here, let's put -2 here. -2, -1, 2 centimeters, it should be 0. It should be 1, 2, 3, 4. So I can put it there. Right there is good. All right. Then on the y-axis, we're going down to a low of -4, going up to a high of 5. But on the y-axis is 1 centimeter to 1 unit. All right. And we can go from -4. So okay, maybe start the negative here. So -4. And this will be -2. This will be 0. This will be 1. Going up to 5. No, that will be 2. Sorry. It should be 2, 4, 6. So it means that our x-axis can be right here at the 0. So this is our x-axis line. We can put it. That's our y-axis. We can put it. That's how we normally kind of work out where you can put the axis, right? So let's do it now. So let's put them in. You'd use a ruler to put them in. Nowadays, I don't even give you these things to do on your own anymore. They tend to scale it up for you. But anyway, my y-axis is going to be on this line where the 0 is. So this line is going to be my y-axis. Draw that again. You have to draw it with your ruler, right? Don't draw it friendly like me. I can't get these things straight with this device. And this is going to be my x-axis right here. So let's just draw it across. That's my x-axis. So x-axis, and that's my y-axis. Let's put in the scale values now. So right here is 1, 2, just like these values I have down here now. This is 3, and this is 4. Right here is -1, Right here is -2. Now my y-axis values, it's 1 centimeter to 1. This is 2, this is 4, this is 6. Then we know to a low of -4. So this is -2, -4. All right, let me take these off now, the guides. Watch over the video and redo it on your own. Let's draw the graph in purple. Let's plot the points in purple or in blue. Let's do it in blue. So the points now. First point is down here, -2, 5. -2, 5. So -2, 5, -2 up to 5 right here. All right, so right here is -2, 5. Then I want -1, 0, which is on the x-axis right here. -1, 0 is on the x-axis. Then we want 0, -3. 0, -3 is right here. Right here, 0, -3. Then we want 1, -4. 1, -4 is right here. Right here's 1, -4. The next one is 2, -3. That's right here. 2, -3. Then 3, 0. It's on the x-axis right here. 3, 0. And then 4, 5. 4, 5. Taking us up here. So 4 up to 5. So that would be right here. Those are your points. And you draw a smooth curve through those points, a smile graph. What's that the graph? All right, Mr. Ellis. What's a young man for me? Draw a smooth curve. You see, the problem is that you guys didn't do the work. Because if you did the work, you'd have more interest. You were making notes, making corrections, and so on. But because I didn't do the work, you just have to be watching me. That's a problem with the online class, when you're just watching somebody do something. When you do the work, you have paper, you're making corrections, you're checking the work, and you're going along. That's the importance of doing the work. Instead of come and just watching me like that. That's the problem. Try the question and you come with your notes, come with your work, and you're practicing. Same thing online. That's why you have to do the work, guys. You have to do the work. That is the graph. It's very difficult to just sit down and watch somebody work, maximum. If you have an interest in it, because you want to see what you get, you want to compare what you did with what I'm doing and all of that. It's a different experience. Easier. You get me? It's easier. All right, so that is that. All right, let's answer some questions here now. It says, complete the following sentences using information from the graph. All right, so from the graph. First one right here. It says, reach down here so now, guys. All right. It says, the value of x for which 3x, that equation equals 0. See here now? This is where the equals 0 now. Here and here. These are the values of x. -2, -1, and 3. Also, basically, this is where the graph on the x-axis. Right here and right here. So -1 and 3. -1 is got the blue, sorry. -1 and 3. -1 and 3. Next value. The minimum value is this -4. Is -4. The lowest y value on the graph down here. Down here. -4. The equation of the line of symmetry. Vertical line through the turning point. This is what it is. Through the axis. X equals x value. X equals 1. That axis of symmetry line, or line of symmetry, if I put it down in purple, will be lined vertical through this minimum point here. All the other points are symmetrical about this graph, about this line. That's the axis of symmetry. It's x equals 1. But the x value at this minimum point is 1. So this is x equals 1. Done. Axis of symmetry. Just stand done. But I did that. Online, you good?
Yes, sir.
So I'm going to give the mock exam next week. I don't have any Easter break here. Turn that from now. Forget about Easter. Easter is to study, prepare for the exam. Some of you doing SBs, have to finish SB over the Easter break. Next question. We copy this over and I'm gonna copy this over into this document. I'm gonna copy this. Hold on a second, guys. Give me a second. Copy this over. Let's put down this document to the right place. Was that was it? No, it was one more this way. Yep. All right. I work with that. All right. Next question, number 5. It says a car is traveling at a speed of 54 kilometers per hour. It's not complicated. All that means is that in 1 hour, it covers 54 kilometers. So in 2 hours, it's going to be 54 times 2, and so on. Also remember that 1 hour is 60 minutes. Right? So if you want to know how fast it's going in a minute, you have to divide by 60. And then 60 seconds make a minute. If you want to know how fast it's going in seconds, you have to divide again by 60. All right? All this statement means is that it goes 54 kilometers to 1 hour. You know, almost do it like a ratio. Almost like a ratio. Calculate the distance in 2¼ hours. So like you have this ratio now. It's almost like you have this ratio now. And you want the hour side to become 2¼ And that way the thing. So for the hour side to become 2¼ you multiply by 2¼ which is 2.25. So if I multiply this ratio by 2.25, which is 2¼ I see what this is. This becomes. Let's get a calculator. So 54 times 2.25. 121.5. That's 121.5 kilometers to 1¼ hours. So the answer there for this question is 121.5 kilometers. That's the distance traveled in 2½ hours. If you want the distance of 2½ hours, you can say, okay, this distance of 54 kilometers after 2 hours is 2 times 54 plus another quarter hour. Quarter of that amount. You want to break it down that way. Next one says, calculate the time in seconds taken to cover this distance in meters. And you're giving this to help now, but coming with the topic of rates of change, I want to show you can do it as a ratio, just to see. So let's look at it this way as a ratio. So that we still have this ratio working with. It's up here. So look at this now. 54 kilometers to 1 hour. And I want to know what 350 meters is. 350 meters. Now, I can bring this to meters first because it's 1,000 meters make a kilometer. So this really is 54,000 meters. So this side is in hours right now. I want to get it in seconds because I want the answer in seconds. All right, so I'm going to bring this to seconds. So 1 hour is 60 minutes. That's 60 minutes. And then 60 seconds make a minute. So multiply by another 60. This is no 60 seconds. This is the amount of seconds in a 1 hour. So I brought the ratio down to that. And I want this side of it to become 315. Can get to become 315 by first dividing it by this amount and then multiply it back by 315. Like this. I want this side to become 315. So like I'm gonna do this. I'm gonna divide by the 5400 to get it to be 1 first. Divide both sides by 5400. And to get it to become 315, I'm also gonna multiply both sides by 315. Multiply both sides. Shift this over. Multiply both sides by 315. Multiply both sides by 350. Whatever this side gives me is the answer. But this side becomes 350 meters. See it here now? So 350 meters corresponds to work this out to get it in seconds. Let's set it up. It's a fraction. 60 times 60 over 54,000. And then multiply that now by 315. 21. So that says 21 seconds. 21 seconds. Time in seconds. 21 seconds is my answer. Do it like a ratio. Just because I don't do this topic yet in the class, just do it like a ratio. But that's the answer right here. 21 seconds. So you start off by what they give you, recognizing that this speed simply means that they go 54 kilometers in 1 hour, like a ratio. Set up like a ratio, 54 kilometers to 1 hour. And they want it in meters and seconds. Convert the 54 kilometers to meters by multiplying by 1,000, and then convert the hours to seconds. So multiply the 1 hour by 60 minutes first to get 1 hour by 60 minutes, and then every minute there is 60 seconds. So it becomes 60 times 60. So this becomes the time, number of seconds in 1 hour, 60 times 60. All right, and then I want this side to become 315. So I divide by the 54,000, carry down to 1, and then multiply it back by 350. I do the same thing on this side. And I get the answer. 350 meters is 21 seconds, and that's it. Simple, just do it like a ratio. This question says, write the following scale. Write the following scale in the form 1 to x. In other words, they don't want any unit. Don't want any unit. So this is 1 millimeter to 1 meter. But it is 1,000 millimeter make a meter. So this really then becomes 1 millimeter to 1,000 millimeters. They shouldn't have put equal in. They should put the 2 as a ratio like this. Right? And so the answer is 1 to 1,000. That's it. So the x is equal to 1,000. Then up here, 2 centimeters to 6 meters. So 2 centimeters to 6 meters. I'm going to convert this side to centimeters first. 100 centimeter make a meter. 100 centimeter make a meter. So it becomes 2 centimeter to 600 centimeter. 6 meters is 600 centimeter because 1 meter is 100 centimeter. And that's it to divide both sides of this now by the 2. And I can cancel down the unit as well. So if I divide 1 by 2, I get 1 centimeter to 300 centimeters, and it can drop off the centimeters. So it becomes 1 to 300. In this case, the x is 300. That is it. Just that, gentleman, for me. Wake up, man. That's why I must do the work. When you follow class, write something, do something, so you can pay attention. Don't just be looking, write something. That's the problem. We don't do the work first. We're not pass, we don't know. We're not joking. Next question. Map scale question. Let's go. This question says, it's a map shown below as on grid of 1 centimeter square. So each of these is 1 centimeter. Each side of these squares 1 centimeter. Right? It's a map. Remember, maps, the distances on a map, and the length on a map will be in centimeters. All right. It says PQRS are 4 tracking stations. The scale of map is 1 to 2,000. So that means that 1 centimeter on the map is 2,000 centimeters in actual distance on the land. All right, 1 to 2,000. It says determine in centimeters the distance of Q to R on the map. That's the here on the map. 1, 2, 3, 4, 5, 6. 6 centimeters between Q and R. QR question said 6 centimeters. 6 centimeters. Let's put in the 6. All right. Determined by counting squares, determined by counting the area in square centimeter of the plane PQRS. That's such a piece of, such a piece of. So what I can do is break it up like so. This is a 3, I counted 3 across here by 4. 1, 2, 3, 4. So this section is a 3 by 4. So inside here is a 3 by 4. That's 12 squares in here, so. And then inside here, so now is just half of another 12. This line cuts it in half. So what you say is half of 12. Half of 12. That is 6. By counting, the total becomes half of 12 squares plus 12 squares. This is 6 and 12 is 18. So it's 18 centimeters squared. Becomes the area of that section, PQRS. Next one says, calculate the actual distance in kilometers. Calculate the actual distance in kilometers between Q and R. That's this one. Remember, on the map, we got 6. We got 6, right? And we want it in kilometers. Now, watch this now. The scale is that 1 centimeter to 2,000 centimeters. That's the scale that they gave us. But the distance that we want is 6 centimeters. So when I multiply this by 6, multiply the scale by 6 or the ratio by 6. When I multiply this by 6, I get the length that we want, 6 centimeters. Multiply this by 6, we get 1,200 centimeters. All right, but I want it in kilometers. All right, I want it in kilometers.
1,200.
Huh?
Didn't you mean like 12,000? I mean 1,200.
I multiply this by 6. And it becomes 12.
No.
See that?
Yes, sir, but you did say 1,200.
All right. All right. Look at what. All right. Okay, but I wrote this. Sorry about that. 12,000. But I want it in kilometers. So first, to get in kilometers, cut this off first to get a meter. All right? Get meter. And you divide by another 1,000. So let's do it this way. So first, it is 120 meters. And then to get kilometers, you divide by 1,000. And so it is 0.12 kilometers. 0.12. So the 6 centimeters is 0.12. So this is the answer right here. 0.12 kilometers. 0.12 kilometers is the distance. Just work out what the 6 centimeters is equivalent to. Because the 6 centimeter QR on the map is 2,000. Scale was 1 to 2,000 centimeters. So 1 centimeter is 2,000 centimeters. So 6 centimeters is 12,000 centimeters. And they convert this now to kilometers. Divide by 100 first to get meters. And then divide by the meters by 1,000 to get kilometers. And that's it. 0.12 kilometers is the answer there. Next one, it says calculate the actual area. Remember, when you want to go to area to square the distance scale. So the distance scale, okay, maybe where do I want it in? Kilometers, want it in square meters, right? So this is the distance scale in meters. This will be 6. Okay, let's use this and go to the distance scale in meters first. All right, what is now? The distance scale first. The distance scale. We're not about to write that. The scale. Yeah, distance is 1 centimeter to how much? 2,000, right? 2,000 centimeters. 2,000 centimeters, firstly, is 20 meters. So it's 1 centimeter to 20 meters. But I want this area in meters squared. So to get area scale, I'm going to square this to get the scale for area. So the area scale, all you have to do is square this one. It's 1 centimeter squared to 20 squared becomes 400 meters squared. 400 meters squared. And then now you want to know what this is. This 18 centimeters squared. That was the area of the map. So now we're going to have to multiply this now by 18. So multiply this ratio now by 18 to see what 18 centimeters squared is. So multiply this now by 18. Multiply that by 18, you see that 18 centimeters squared to multiply this 400 by 8. Let's use it over here. 18 times 400. So you get 7,200. 7,200 meters squared. That is the answer. That's 18 centimeters squared on the map, 7,200 meters squared on the land. That is it. All right. But okay, with that, next question done. If you didn't do it, you need to go and do it. If you didn't do the questions, you need to go and do them. You need to go and do them. That's how it works. And the question you didn't do, you can do it now. You need to go and do it by yourself. All right, let's continue. Next question is number 6. All right, this looks like a solid geometry. All right, measurements. It says the diagram below not drawn to scale shows two cylindrical water tank, A and B. All right, it says tank B has a base diameter of 8. So for this one, the diameter is 8. We're not going to work with diameter. I'm going to go just right from now. For this one, the R equals 4. The radius of this one is 4, the small one. The radius is 4 meters. We're working in pi r squared on this. We're not working in diameter. So the radius is 4. And the height is 5. So let's call this height H is 5 meters, sorry. It says both tanks are filled with water. Well, this can call this one H. So I can't call it one H now. I can call it one H already. All right, this 5 centimeters, no problem. It says pi is 3.14. Here it says calculate the volume in tank B. So remember, it's a cross section here times the length. All right, so the volume in tank. I think I give the formula for volume on this paper too. You know. Let me see up here. Here is it. So the formula sheet here. Volume of a cylinder. See it here, so I give it here. So it helps 4 pi r squared H. Pi r squared H. All right. Pi r squared H. All right, so let's calculate the volume of tank B, the small one. So the volume in tank B is pi r squared H in tank B. All right, that becomes 3.1. Let's write it. 3.14 times the radius is 4 squared, and the height is 5. That's what we're working out. Let's get a calculator and work it out. That's what we're working out. So it's 3.14 times 4 squared is 16 times 5. And within 251.2. 251.2. That is what? Meters cubed. Meters cubed. Next one says, if the area of the base of A, the big one, the base area is this. Calculate the length of the radius of base A. So in other words, what they're saying is that the area of the base is 314. So it basically like said pi r squared, that's the area of A, is equal to 314. To tell you what the area is, and I want you to calculate the radius of A. So if the area is 314, that means that pi r squared is this. So remember that pi is 3.14 now. I think it's 10 we're gonna get, because this is 100 times that. So it's gonna be 10. So you can work it out. 3.14 times r squared of A is equal to 314. We divide this by that to get 100. Same number getting 100. So the radius of A squared is equal to 100. So the radius of A is 10 meters. When you square root the 100, you get 10. All right? So it's 10. Calculate the radius. It's 10 meters. Next one says, tank A holds 8 times as much water as tank B. 8 times, Tank A is a bigger one. So it means that the volume in A is equal to 8 times the volume in B. Did we calculate the volume in B up here? Oh, it's here. We never write it. 251.2. We wrote it. We're gone. Meters cubed. We're gone. We undo it accidentally. 251.2. So the volume in B is going to be 8 times. So calculate the height. Let's do the volume first. 8 times the 251.2. Let's see what that is. So it's 8 times 251.2. So that's 2009.6 meters cubed. That's the volume in B. But we want to calculate the height. Remember, we have the base area of B, See it here now? We already have the base area of B. They told us up here that it was 314, the base area of A. Right? Now they want us to tell them the height of A. So we can use this. Volume equals base area times the height, or the length, which is the height. Let's use length. V equals AL. Remember? Talking about the A1. We're trying to find the L. So divide by the A. So the L becomes the volume of the tank over the base area of the tank. That's all I mean. So length of the tank, which is also the height, becomes this volume, which is 2009.6 over the base area, which was 314, the total up here. Here, the base area is 314. We're not told to get the height of the tank. So it's 2009.6 over 314. 6.4. So the height of that tank is 6.4 meters. That's the answer. I put L because I want to keep it consistent with the formula that we learned for volume. The volume is end area times length. That's the length and the height is the same thing. So this is the answer. That's the height of the tank. All right? And that finishes that part. All right. Then we'll come to our transformation. Just answer. The diagram below shows triangle PQR and its image P prime Q. Some things about this one right away. So, for example, the scale factor is negative. I want to know that. Because the image and the object pointing in opposite direction. For example, here, R to P is pointing down, but R to P and this one is pointing up. So that means that the scale factor is negative. What's the value of the scale factor now? This side, for example, is 2 units. The QR is 2. But this is now 4. This was 2 and they go on to 4. It means that there's a scale factor of 2. It times it by 2. Length, but it's negative. So the scale factor is actually negative 2. All right? And then the center of the enlargement is here. And you can also That's it. And it said the center of enlargement at point C. What I'm saying now? It says use information from the diagram, complete the following state. The size of the scale factor is 2. The scale factor is negative because of, why is it negative? Why is it negative? I would say because the image and the object pointing in the opposite direction. I can say the image is inverted on the opposite side of the center. Those are the reasons when the scale factor is negative. Right? The image and the object pointing in opposite direction, or I can say the image is inverted on the opposite side. See, they are on the opposite side of the center. Look, like this. If I join these 2 points through the center, the center here, they are on opposite side of the center. So the image is inverted on the opposite side of the center. Can I write that? And pointing opposite direction. Write out all of that. The image is inverted on the opposite side of the center and pointing in the opposite direction. Why is it scale factor negative? I'm going to say the image is inverted on the opposite side of the center and pointing in the opposite direction. I want my full marks. I'm giving them everything. I want the 1 mark. I want it. I want to answer it fully. That's it. So when the scale factor is negative, you can know that the image of the object will be on the opposite side of the center. And they are pointing in opposite direction. That's why. But the size of the scale factor, you can't put the negative on it. When it says size, they don't put the negative on it. The scale factor is negative 2, but the size is 2. And the thing becomes twice as large. All right? That's that. Next one says, the length of PQ is the root 13 units. Therefore, length of P prime, Q prime is twice. 2 times, right? 2 times. So we're going to write 2 times the square root of 13 units. So scale factor, double it, right? That's it. Scale factor is 2. So scale factor, double the length. Next part says, the area of triangle PQR is how many squares? So we're going to look at the triangle and see what the area is, right? Let's see. This is the base, this is the height. The base is 2, the height is 3, half base times height, right? That's 3. All right? Half base times height, that's 3. So let's do it, it's 3. So it is equal to 3 squared units. Why? Because it's half the base of 2 times the height of 3. Which is equal to 3. That's what we get is 3. All right, that's that. This part says the area of P prime, Q prime, R prime is something time. How much times? That's the image, you know. This is testing your knowledge now. The area of the image is what times the area of the, this is the area of the object. This is the area of the object. This is like AO. And this is the area of the image. This is like AI. This one is like AI and this one is like AO. What's the relationship between the image of the area of the image and the area of the object? Who remembers? Which side do you remember?
The scale factor or something, right?
The more the precise thing, mathematics is the exact science. The more the exact answer is. What's the relationship between area of the image and the area of object in an enlargement? I'm going to tell you, you must know these things and I don't know it. And if you know the thing, you must know because the common exam paper. But the center teacher teaching you something, I said, you must know this. And I still don't know it.
Yes, you hear me?
Yes.
Sir, I was saying that the enlargement, sir. The scale factor.
No. When it comes to area, I'm going to tell you again, this will be the last time. Area of image, I'm going to put up chart and everything, going to put up square and show you why. Area of image is k squared times the area of the object. Area of the image is k squared times the area of the object. I did a demonstration in the class to show you why that was so, and as I put on the must-know sheet, what we did the transformation. It was on the must-know sheet for the transformation. You guys joking. You don't know these basic things. Let me give you a sheet of things that I said. You must know these things. And this is on it. And no one get a question about the blank. Area of image is k squared, the scale factor squared. Times you have the object. We have done this multiple times. You guys joking. Exam is around the corner. I'm not joking, man. I'm not serious about this thing. I'm not joking. Not serious. I'm not serious. So I bring up a must sheet and show. I think I joke, man. We're supposed to have it in here somewhere. No, I'm going to prove it. So I'm going to have it and give it to him. Find it. It's in here somewhere. That's joking. I'm not spend time in the class and do this now. Okay, I'll just show us a work for the paper. What is the topic of transformation? We are looking around the place. Teacher, transformation must know. You all have this document here. Let me say you must know everything on this. See it right here, and I make it right here, so. See it there. See it here, so. Our practice questions with it. Area of image equals k squared area of object. I'm going to write it like this too on the board. Area of image equals k squared area of object. You guys will go in an exam room, see things like this and say, I never seen this before. So you never teach me. And it is on a document called must know. Transformation must know sheet. Things that you must know. So what the sense? When I have this, I gave you all this document. What the sense? What do you do with it? I'm not joking. I'm not serious about this thing. I don't want to pass the exam. I don't want to work for pass the exam. I don't want to pass the exam without putting in the work for it. The question I asked you a while ago. Why is the scale factor negative? See it here? See? See it here, sir? Image, when the scale factor is negative 2, image is twice as large, twice the distance from the center, inverted on the opposite side of the center. That's what the question just asked us to do a while ago. You know? The question I just did. The same scale factor of negative 2 question. And I ask you, why is the scale factor negative? This is the reason. Come on right back. Inverted on the opposite side of the center. See there? Image is inverted on opposite. And when we're doing the class, I said, right on your hand up, at the street, and pointing in the opposite direction. We added that to this statement right here in the class. My teacher work hard. I tell you now. My teacher work hard, I tell you. Because me, we go through many questions with this very thing. We go through so many questions with this very thing of that enlargement thing. Transformation enlargement. Why would I do that? Because the CSEC report says every time them give a question like that, people not using the case square.
Sir, you got cut off, sir.
Sure. Can you hear me now?
Yes, sir. But you got cut off like 2 minutes ago, sir.
I hope it's recorded, you know, because we're here online, so I hope it's recorded. I don't know what's happening. I get me upset, man. Sure. Listen, what teacher tell you say you must know something and you don't know it. Teacher say you must know this. give you examples. I want to still come to class, like at the first time I want to see. You want to be in there? Huh? I don't understand. I don't understand this. I'm telling you, I don't understand it. I don't understand. I don't similar as a paper no better. See there? This is the area of the image. Area of P prime, Q prime. That's area of image, you know. Is the scale factor squared something times it? This is testing your knowledge of this. K squared. Well, you know scale factor is negative 2. So you're gonna write negative 2 squared. Negative 2 squared, which is actually 4. It becomes 4 times. Well, that's how to get the 4. Negative 2 squared is just 4 times using this knowledge that everybody should have inside this class. 4 times you have triangle PQR. PQR is the object. You have the object, and this is the image. Which is 4 times the workout already. 4 times 3, 12. Which is 12. If you go up on the triangle, you have to start 12 for 2, you know. See triangle up on the diagram? The base is 4 and the height is 6. Half base times height. 12. What do you want you work it out, so? You're testing your knowledge of this. When we saw the most know this. That's why the question set up that way. You could have easily asked what is the area of the triangle, people. But they're not setting the question that way for you to go and calculate after the graph. You're testing your knowledge of this thing. You just get me upset, man. It's 4 a day. After I win champs yesterday. Let me get upset now. It don't make no sense. The teacher said, know this, and I don't know it. It don't make no sense. The teacher said, you must know this thing. So that when you get it on a question, you can do it. And they don't come like blank like I never seen it before. I will do much examples with it. I will always say, go home and redo the examples that we do in the class. Redo them to cement the information in your head. Go home and study the must know sheet. You don't want to pass exam and you don't want to do the work. You want to pass exam, but you don't want to do the work. It's things like this. Let me know so you not do what teacher say on the product. You don't want to get success. Just coming inside there looking at me, can't give you the success. You know? What will give you the success if you don't do what I'm telling you to do? We're not doing it. We're not doing it. Let me tell you something, man. See, over the years, any student who do everything that you tell them must make the Caribbean top 10 list. Must. And we can know the students who I know from class time, the ones who used to always be doing anything we say. Do this, do that. They're doing it. They're doing it. They always make the top 10 list. Performance list. Because they do everything you say. They say, study this. Make sure they go and work on the paper and say, make sure I know everything on this. So I say, know everything on this. No. So I say, go and redo the question, go and redo it. So I say, this, them do it. Anything we tell them to do, them do it. Can't fail. Cannot fail. Can't fail. Must make the performance listing every time. If they make it in Jamaica, they make it at them school. They make it at them school, or they make it in Jamaica, or they make it in the Caribbean. But they must make the performance list somewhere, anywhere them there. Must. Them people there. Come on, man, I joke, man. I get me upset, man. Now do the work. Things are supposed to fly off on a tip on a finger like that. Huh? So we do from before December. These things. From before December. We do that. We don't do them early for them to forget them, you know. We do them early for them to be cemented. I have more time to revise it and do it over and over again. That's why we do it so long ago. to cement it. These things. That's how the transformation so early. So we get a chance to do it over and over again. How much question we do with that? I don't come like I never said that before. I'm depressed, my man. I'm depressed. Number 7. The line graph below shows the monthly sales in thousands of dollars at a car dealership for a period. I know the starting about a question there too. Remember, what is the topic now? We do all of them pass for a question already. What we doing now? On the transformation, we do a set of pass for question and transformation, including this one. So we do the question already, this particular question. For the question, I don't know, all of them are like repeats. As we did the topics, we do the past for them. For those topics. That's what we should do on the Saturdays. So the sense when you get exposed to a question. Any question you see done before. Once you see it again, you must know how to do it. Any question you see done before. Once you see it again, you must know how to do it. You make yourself know how to do it by doing what? Working it over 3-4 times till it's sticking in your brain. You can do it by yourself. Once you see it done before, and you come across it again, you can do it. Or anyone like it, you can do it. You guys not prepared to do the work. You're not prepared to do the work to gain the success one want. That's a problem. All right. So this is in thousands of dollars. For example, this 40 means $40,000, right? And these are the months. So these are sales figures in thousands of dollars in those months at the dealership. That's what I want now. So for example, in August, they sold $20,000 in August, right? For example. All right, let's see what I want us to do. It says complete the table below to show. See, they've asked us for August. So July was 13, right here is 13. So August is clearly 20. See here, August is clearly 20. I'm going to put that 20 right here. Then they're asking us for October, right here. This is 25. Or you're halfway between the 20 and the 30. This is 25 October, 25. And then November, sorry, right here, November is 15. Halfway between the 10 and the 20 is 15. So right here is 15. So complete the table, and it's in thousands of dollars. All right. Next part says, between which 2 consecutive months was there the greatest increase in sales? Greatest increase. In other words, when the increase was greatest. You can know that from a graph by looking at the gradient of the graph and the length of the line segments. So the one with the highest gradient and the longest line segment is one that actually had the greatest increase sloping up. We could also look at the values here. So from here to here is an increase of +7. From here to here is an increase of +16. This is a drop of 11, so you subtract. -11. This is a drop of 10, so you subtract 10. So the greatest increase in this year, so between August and September. All right? Look at the numbers. Let's look at the graph now. Here, August and September. Look at it. The longest line sloping upwards, longer than this one. Plus, it is steeper than this one. That's a gradient of that way. This gradient is less. See? A lower gradient. So the one with the highest gradient and the longest line segment is one of the greatest increase. So you can get it from the graph or you can get it from the values in the table. So between August and September, that period. Between August and September, right? See here, August and September are the greatest increase. August and September. All right, next one. Between which 2 consecutive months was the smallest increase? Increase them still enough. Increase. So still want to increase. Increase is a positive gradient going up. All right. So in terms of the numbers, the smallest increase is this one right here. So in terms of the graph, it will be the shortest line that will be a positive gradient. Shortest line with the lowest gradient, it must be a positive gradient. This one right here. July to August. July to August. So July to August at the smallest increase. Watch this now. What feature of the line graph enables you to infer between the consecutive months which greatest or smallest? What feature of the line segment of the graph tell you that? I just said it here. Tell me, what feature of the line can tell you when you have the greatest or smallest anything? I just said it there. What you know from the graph when you have the greatest increase? I just said it there. Huh? The highest gradient or the longest line segments. The length of the line segments and the gradient of the line segments is what tells you greatest or smallest. Gradient and the length of the line segments. Does that feature the gradient and the length of the line segments? Gradient and length of the line segments. All right, that's it. Next part says, calculate the mean monthly sale for the period July to November, the mean. So you're going to add them up and divide by the number of values, July to November. So you're adding up these values. I divide by, how many values are there? 5. 1, 2, 3, 4, 5. All right, let me do it right here. It's going to be 13 plus 20 plus 36 plus 25 plus 15 divided by 5. Remember, you're in thousands, you know. You're in thousands. Where this work out? Let's work it out over here. Let's work it out over here. And I want to copy it down. I'll move it down. All right, so add them up and divide by the 5 values there. So it's 13. Let's do the fraction. Fraction 13 plus 20 plus 36 plus 25 plus 15 over 5. So it's 21.8. 21.8 thousand. 21.8 thousand, right? So what you can do now, you can say that is $21800. If you want to put it as money, that's the average, you know. Right? So let's copy this down now. I'm gonna cut and paste it down right inside, yes. That's it. All right. The mean monthly sale is 21,800. The average. Because this is thousands. But these values are thousands, you know. So you get 21.8 to get the actual amount, they put the money on it. Dollar sign. So let's write IE, that is 21,800 multiplied by 1,000. That's the amount. All right. But good at that? But okay with that?
Sure.
All right. All right. So the total sales through to December now is this 130,000, right? Calculate the sales amount in dollars. Calculate the same amount in dollars in December. So remember that this up here represents the total sale up to November. Right? And now they're telling us that the total sale up to December is actually 130,000. So if I multiply this, take about the 5 of this calculation, the total is 109. So let's look at it this way. This up here is 109. This that we have. right here, so is 109. So tell me if you can see. This equals 109,000. But up to December is 130. So if I say how much they add now to get the December figure, right? If the total of the December is 130, but up to November 109. Then the difference is how much they sold in December, that's all? Good. So the total up to November 109. I'm leaving 109 on my paper here now. All right, and then this down here, so now is actually 130,000. So the sales for December is 130, sorry. It's going to be equal to 130 minus 109,000. What's your report? 130 minus 109. That's 21. I.e., I'm saying in dollars, 21,000. If you go to 21, that's $21,000. 21, put the dollar sign in front of it. $21,000. $21,000 is the sales in December. I know, right? That's it, $21,000 flat. Next one more. Complete the graph to show the sale in December. Sale in December was 21. So we'll put on 21 on the graph. Let's put 21 on the graph and extend the line. 21. So see now the graph. Let's go back for it now. Extend the line. 21. So the graph here. First thing you can't put December right there. So what is this? Every 2 centimeters make a month. That's the first thing. You can't put December right there, so otherwise you're wrong. Right? Look at the scale. So December is after 2 centimeters right here. That's where December is gonna go. And it's going up to 21. It's 21. So 20 here. This is 21. This line is 21 right here. So 21 is this line. And this is December. The point that you want is right here. Put on near it so you can see. So join it to a straight line like that. That's it. That's the figure for December. That's the line there. Let me tell you this off. I'm showing you how you get it. But this is December. Right down here is December. That's the December line. That's the graph completed now. Put on the extra piece in red. But understand that? Good. What else is there to do with this? Question done. All right, so we have 3 more questions in section 2. Let me have a question with the class of longer than normal, but that's how it go. 3 more questions. Let's do them quickly. All right. Pattern question. Oh, number 8. It's 4 more questions we have. Osh. So number 8, 9, 10, 11. There are 4 more questions. But this can be done quickly. This question says a sequence of figures is made up of equilateral triangles called unit triangles with unit sides. The first 3 figures, the sequence are shown. Draw the 4th one. So let's look at what is happening now. So basically, the length of the side here of this one was 2. Let's look at this. Look at this. Length of the side of this one was 1 first. And then this one now, the length of the side is 2, and then put 2 unit triangles in it. Then this one came to 3. And then so the next one is going to be 4, right? So let me take this that we have already. Let's look at it. Let's be smart. Take the one we have already. I'm going to make this side 4, make this side 4, make this side 4 now. By just extending, right? I'm going to extend this out. 4, 1 more centimeter. 1 more this way. And then now come straight across here. And then we have complete some 1 centimeter triangle inside this. I don't know. Like that. So. Alright, must have 4 marks. 1. I divide it half and half. It's 4. Right, like that. So 1 triangle there, 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 so That's the extension. Oh, and one here, so two. So now 4 triangles on the base. Like that. And then we complete the rest of it now. That's how it would look. Let me copy it down, but let me draw it from scratch though and show you, because I'm copying what we had before. But let me see if I were to draw it from scratch and show you. So if I was to draw it from scratch, I would draw an equilateral triangle of 4 centimeters long on each side, right? But this is 3. So I'll go like this. I'll draw a line 4 centimeters this way, 4 centimeters that way, 4 centimeters that way. All right, I'm going to break this side into 4. So I cut it in half, cut this and cut this. That's 4. Cut this in half, cut this in half, and cut here so, cut here so, cut here so, cut here so. I'm going to join the horizontal lines first. So go like this, like that, like that. Now this line is supposed to be 3 centimeters. 3 centimeter marks on it. So I'm going to mark it with 3 centimeters. 1, 2, 3. 3 centimeters. This one is 2. So let's divide it half and half. Like so. Right there. And this is 1. So let's complete them now. Bam, bam. Join them. Bam, 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 bam. Join these. Bam, 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 bam. And that's how we'll draw it in an example. Done fast. Right. That's the same thing like this. Just that this one now I copied it off, that's more accurate than this. But that's it. So I use a protractor and all of those things. I use a ruler. You draw an equilateral triangle. It's a 60 degrees, 60 degrees, 60 degrees. 4 vertices, 4 angles here. These angles are all 60-degree angles. As an equilateral triangle, yeah. But I'll make the size the 4 centimeters, 4 centimeters, 4 centimeters. Get my 4th diagram. But that is it. Next question now says, so the pattern of numbers in each row in the table below. Each row relates to one of the figures in a sequence of figures. Some rows have not been included in the table. Complete the rows number 1, 2, 3, and 4. All right, let's look at the patterns now. So look at this column. I can see that it's the perfect square of these. See, this is square of that. This is square of that. This is square of that. So I mean that this is n squared. This column is an n squared column. This one, sorry. The n squared column. My mistake. This is an n squared column. N squared. Let's look at this one now. So the figure number is always right here, so see there? And the figure number is also right here, so. All right, so let's put the pattern. And this is always a 3. This is always a 1. I always divide them by 2. So this is like 3 times n. This one, this is like 3 times n. This is always n plus 1. So it's 3 times n, n plus 1. So this becomes 3 times n. 3 times n bracket n plus 1. I put 3 times 1. 3 times n bracket n plus 1. And they divide that by 2. All right, so it really works out to be 3n into n plus 1 over 2. That's what it is. All right, let's fill this out now. So for 4, you're going to get 4 squared, right? 4 squared. And put a 4 squared there is equal to 16. I'm using this same pattern up here, so now. So it becomes 3 times 4 now. 3 times 4. 3 times 4 bracket 4 plus 1 over 2. All right, what it equal to? What is it equal to? It is 12. It's 12 times 5 over 2. 12 times 5 over 2, this is 30. This equals 30. This one is 30. This one 144. Now this is 144. This has to be 12. What can I say that? What can I say that? Because 12 squared is 144. Right? So we got this. So the number becomes 12 now. So you put in a 12 here and here. So it becomes 3 times 12. This one becomes 3 times 12 times 12 plus 1 over 2. Write that out for me. 3 times 12. Write it out. Therefore, what it equal to. Therefore, what it becomes is 3 times 12 fraction. 3 times 12 bracket 12 plus 1 over 2. Bracket this up first as well. Over 2. 234. This becomes 234. 234. All right. Next one. This is 25 now. So we get 25 squared right here, so which is what, 625, I think. 25 squared. Which is 625. Yes, correct. We're using the formula again. So it becomes 3 times 25 times 25 plus 1 over 2. Let's write that out again. Fraction. 3 times 25. Let's bracket it up. And let's start talking on there. Plus 25 plus 1 over 2. This is 975. This one, 975. First and done. All right, that's that pattern. They didn't want it to do any magic with this one. Let's work it out. That's it. Straightforward. Number 9. Let's go. It's a teacher marks an exam out of 120 marks. It said the marks are then converted to percentages. Calculate the percentage for a student who got 60 marks. That's 50%. See? 50%, not it? 50%. That's half the marks. A person who got 120, 100%, not it? Get everything right. 100%. If you get 60 out of 120, that's 50%. If you get 120 out of 120, that's 100%. It says on the graph on page 27, plot a graph to show information. All right, so that's what the graph is. Okay. So to give the percentages up here, we are going to have to put on the marks down here. The marks is up to 120. Let me see if I'm seeing a scale anything. Nope. All right, so we're going to put on the horizontal scale and then plot these points. So we're going to have to 120 marks, guys. So we're putting 120 marks down here. So can we go 10, 10, 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Good. That's 10, 10 we have to go. So let's put them on. So we're going to put 20 here. So 40, 60, 80, 100 marks, 120 marks. So remember now, 60 marks is 50%. 60 marks is 50% right here. That's a point. Come on, give class. All right. So put that point right here. Right here. 60 marks is 50%. And then 100 marks is 120 marks, sorry, is 100%. 120 marks is 100% right here. Right here. So right here represents another point. And then 0 marks must be 0%, right? So a straight line through this now becomes your graph. A straight line through here becomes your graph. Is you roll and draw a straight line through this, like that. And that will be the graph for the grades. So based on this graph now, for any grade down here, you can go and get the percentage. Or for any percentage up here, you can come and see what marks the person got, all right? But we can, the thing about this is easy. We can work out the calculation and see what the values are supposed to be. See if you match the graph. All right, so that's the graph. First question says, it says, draw lines on your graph. All right, so this one says, a candidate was awarded 95 marks in exam. Use the graph to determine the candidate's percentage. Now, we can work it out, you know. 95 out of 120. Just to be sure. And then you see the graph gives us that same value. So 95 out of 120 times 100. So it's supposed to be 79 point something percent. So you're going to go for 95 marks on the graph and see what it tells you. You're supposed to get 79%. 95 marks. Let's see it here now. So 95 marks. First, you have to read the scale and see where 95 is. So right here, so it's 90. So 95, let's do it in purple. 95 must be right in the middle between here and here. That's 95. This is 95. And so you come in there on the graph until you reach the red line. This is what percentage it is. You have to do it with a ruler, right? Don't do it like me. See if we get 90 come across here. $79. See that? And write the 79. But if you do this with a ruler, it might be better, right? But I get 79.16. I'm going to give them a 79. It's actually less than 79 give it me, you know. Now look here. This is 70, 72, 74, 76, 78. Up here, 79, you know. Still I put 79. Still put in 79. I prefer to adjust the graph and get my 79. I'm lucky. I make it less than 79. I just thought I didn't draw this with a ruler. If you draw it with a ruler, it will be more accurate. It will be more accurate with a ruler, but I'm gonna go and extend it up here and put this line to come up here. So okay, up to 79. Telling me 79%. You can't give me something I can calculate and I go and get it wrong. You mad? I'm not doing that. 79. I should draw lines on the graph to show those are my lines. 79%. 79% is the answer. All right, 79%. Next question says, a candidate was awarded a grade A if he scored 85% or more. Use the graph to determine the minimum mark that he must get a grade A. So you want to know what is 85% of 120. You know what the mark is. I'm going to work out 85% of 120. 85% times 120. I'm supposed to get 102 marks. Let's see if the graph gives us. So we're looking for 85%, I must get 102 marks, right? Let's look at it. So 85% would be, so this is 90 and this is 80. This is a different color. This is blue. 85% would be right here, right halfway between the 80 and the 90. That's 85%. Come across the graph right in between here. And it's 82, is 102 I'm supposed to get in. You're not getting no less than that. I'm sure I get 102. You're not lucky. which is 100. So 110. So this line will be 102. This line, 102. All right. So 110. So 102, 4, 6, 8, 10. I want 102. All right. So it means that this graph is supposed to be a little bit higher. This graph here. A little bit too low. Supposed to be higher up here. That's where it's supposed to be better. All right. So I'm going to stop it here and put that 102 right here. And give them 102. So right here, we're 102 on the graph. So I'm coming down here now and tell him 102 marks. Minimum mark will be 102. That's it. Easy question. Next part, a quick functions question. It says f of x is this, g of x is that. We want g of 5, we're going to put 5 up here in the g function. So this becomes equal to 5 squared minus 1 over 3. That becomes 25 minus 1 is 24 over 3. That becomes 8. An expression for f to the minus 1. Let's start with this f function here. And say f equals 3x plus 2. Inverse that, the f becomes x equals 3 times f to the minus 1 plus 2. Make this a subject. Transpose the 2 first, you get x minus 2. Then divide under the 3. Divided by the 3, that leaves us f to the minus 1. So basically, that is it. So this means that f to the minus 1 of the x is equal to x minus 2 over 3. That's the answer right there. They want us to write an expression for g of f. Now remember, g of f means the f into the g. F into the g. So it means that we are taking this f and bring it and put it into the g right here where the x is. All right, that's what it's gonna become. It's gonna become 3x plus 2 squared minus 1 over 3. That's what it's gonna become. We'll put the f into the g. It's gonna become this. All right, so I'm gonna copy this down now. I'll copy and paste it down. It's gonna become that g of f. So g of f of x is gonna become this. But I want us to simplify it down to this format, factorize it down. So let's expand out the numerator. It's gonna become, you square this first, you get 9x squared. Then twice the product of a 2. You multiply this and this, you're gonna get 6x, double that to 12x. And then you square that as well, you get 4. But 4 minus 1, this is 3. So you're gonna actually get 3. 4 minus 1 is 3. And divide that now, put a 12, I need a 12 right there, so by 3. And each of these values can be divided by 3. Therefore, it becomes 3x squared plus 4x plus 1. But I want us to factorize it. So I factorize this quick and fast. But these are easy numbers as well. Again, 3x and x, 1 and 1, everything positive. Plus, plus. Far product is 3x. Near product is 1x. 3x and 1x is 4x. So I don't say that's right. That finishes that question. All right. You go home and watch over the video piece by piece if you have to. Next question. It's a elevation test. It says the diagram below not draws the scale shows a vertical to a BT. This is a vertical to a BT right here. With a flagpole TP on top. It says it's a point R on the same horizontal ground as B is such that RB is 60 meters. I'm going to put on the diagram now. This is 60 meters. 60 meters. Then it says the angle of elevation of T and P from R are 35 and 42 respectively. Let's set it up. It means that this angle up here, what angle them say? 35 and 42 is 35 degrees angle of elevation looking up. But this angle of elevation is 42. This one is 42. 42 degrees. All right. Question said, label diagram to show the 60 meters. See it there? The 35 degrees. See it there? 45 degrees. See it there? It's any right angle. That's angle between the horizontal and the vertical. Right here. This is the right angle, 90 degrees. That's the diagram now. Easy. So we have two triangles working in. We have this small triangle, which angle is 42 degrees. But this larger right angle triangle, where the angle is, no, sorry, the small one angle is 35 degrees, large one angle is 42 degrees. Now let's see what I want. Calculate length of the flagpole. Length of the flagpole is the overall height on the big triangle minus the height on the small one. That's the flagpole. Right? So we're going to work in the two triangles. So let's set it up this way. The big triangle first. Triangle PBT, the big one. Triangle PBT. Want to get the overall height. The adjacent is 60. I want the overall height. I'm going to use tan, and angle is 42 degrees in the big triangle. Tan, opposite and adjacent, tan. So I'm going to say the tan of 42 degrees equals the overall height PB over the adjacent is 60. So multiply the 60 up here, you get PB equals 60 tan 60 and the tan of 42 degrees. In the other triangle, the small one, get the same thing, similar thing. Triangle TBR. So we use wrong thing, wrong to write this in. It should be T, the big triangle. This is PBR. Next one is triangle TBR, the small one. Tan again. This time is tan of 32 degrees. Equal to opposite side now, which is just TB over 60. So multiply with 60, TB equals 60 times the tan of 32 degrees. So length of the flagpole difference between these two distances. Overall height minus the height there, so that's a flagpole length, right? So length of flagpole, let's just write so. Length of flagpole is this PT. So let's write PT equals this minus that. 60 tan of 42 degrees minus 60 tan of 32 degrees. Of 35 degrees. 31 is me write foolishness and answer nothing. Angle is 35. The angle is not 32, it is 35. You guys are still waiting for the class to end. That's what we're working out. Height of the flagpole PT. I want to write equals PT up here. So we calculate PT, that is it. So 60 tan 42 minus 60 tan 35. We factorize the 60 as well. So 60 tan 42 minus 60 tan 35. 12. So to the nearest meter, 12 meters. That's the answer, 12 meters. To the nearest meter is 12 meters. All right, that's that. Next one, a bearings question. This question says, diagram below not drawn to scale shows the relative position of fishing boats, K, L, and M on a bearing. L is on a bearing of 040 degrees from K. So let's put that on the diagram. So from K to L, the bearing is 040 degrees. That's this angle right here. This angle right here. Let's put on the diagram, 40 degrees. Let's put it on there. This is 040 degrees right here. All right. And I said the distance is, it says K from K, and M is due south of L. See, M is due south of L. So that's a straight vertical lines. So these two lines parallel now. These two lines parallel. That's a north-south line. That's a north-south line. All right. It says that distance here is 120. So that's on the diagram. And this distance is 80. So because of this Z, the angle inside is 42, you know. Z angles, 40 degrees. On the diagram should bring us 040 degrees. That's it, done. Next part says calculate the measure of angle KLM right here. That's 40 degrees, you know. Z angles. This vertical and this vertical, Z angles. So this angle is 40 degrees, KLM. Equals 40 degrees. See, one mark for it because it's so easy. So this angle inside it says 40 degrees. Then now they want to calculate the distance km over here. Cosine rule for that. Cosine rule for km. Distances are 80, 120, angle between them is 40. Let's go. Cosine rule. So the km is going to be the square root. I'm putting the square root now of 80 squared, 80 and 120. Of 80 squared plus 120 squared minus 80 times 120 times the cosine of the 40 degrees between them. That's what you're working on for km. You must try to be quick and fast. Square root, cosine rule we use. 80 squared plus 120 squared, start like Pythagoras theorem. You subtract a piece. 2 times the 80 times the 120 times the cosine of the 40. It is 78 to the nearest kilometer, that's 78 equals 78 kilometers. What else I want? Calculate the measure of angle KLM. Let's put on what we want there. This distance is now 78 right here. 78 kilometers. Which angle do I want? Let's say angle LKM. Angle K. Angle LKM. The one angle inside here. Let's call it angle alpha for now. When you use cosine rule, this pair over here, so with this pair over here, so. Not cosine rule, sine rule, sine rule. But we have a known pair opposite each other, angle and side. When you use sine rule now, let's do it right here. Beside it. Sine rule to find this angle. So it's sine of the alpha over the side opposite alpha, which is 120, equals sine of the angle that we know, which is the 40 up here, over the side opposite to it, which is the 78. Let this 120 and multiply it up here and I get the answer. So, and then take alpha. So alpha equals sine to the minus 1 of 120 sine of 40 degrees over the 78. I'm going to copy this down. Let me work this out. So that becomes sine to the minus 1, a fraction, 120, and the sine of 40 degrees over 78. That's 81. It's an angle in degrees, you know, so I'm going to put 81. So to the nearest degree, 81. 81 degrees. Another one, the bearing of K of M from K. Remember, you have to note the from position. So it's from K to M. From K to M. So from K to M on the diagram, see? From K down to M. Let's put on in purple. So measure from here. That's an outline. That's a line down to M. They want this bearing angle, which is 40 plus alpha. 40 plus alpha, K to M. All right? 40 plus alpha. So the bearing of from K to M equals 40 degrees plus alpha, is alpha, which is 40 degrees plus 81 degrees equals 121 degrees. That's it. Yeah? I'll show you the question next time. That's easier when you do the questions first. Easier. All right? Next question. Last one. Matrices. Must can fly through this quick. I don't think I need a calculator for this last one. Online is still there with me? And some people drop off.
Yes.
Still there. All right. Let's go. Let's finish this. Calculate the product of these two matrices. Multiply them. Let's do this quickly. We'll multiply them. Let's write it out. 1, 1, 2, 3. That's the A. Times 1, 2, 0, 1. Remember, you multiply the rows of the first matrix by the columns of the second matrix. It's going to be equal to 2 by 2 matrix. Let me shift this over a bit. It's going to be equal to a 2 by 2 matrix with 4 values. Let's get the red. Ready? Let's go again. The first value here is in the first row, first column. So to get to using this first row, this first column. First element times first element, second element times second element. First element times first element, second element times second element. 1 times 1 is 1, 1 times 0 is 0. And this value out here now is in the first row, second column. First row, second column. Same thing again. First element times first element, second element times second element. First element times first element, second element by second element. 1 times 2 is 2, and 1 times 1 is 1. Then this value down here now is the second row, first column. Using this second row, the first column. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 1 is 2, 3 times 0 is 0. And the last value down here is the second row, second column. Second row, second column. So 2 times 2 and 3 times 1. 2 times 2, 3 times 1. 2 times 2 is 4. 3 times 1 is just 3. And then we're going to finish it off. This is 1. This is 3. This is 2. And this is 7. That's the answer right there. Plenty. Show that matrix product of A and B is non-commutative. That is, AB is not equal to BA. I can start working out BA. So this was AB a while ago. I can start working out BA. It's okay. BA, I'll have to switch them around and put 1, 2, 0, 1 times 1, 1, 2, 3. I was just to calculate the first value right here and shows that it's different. So the first value here now is the first row, first column. Using this row and this column. So already know. So in first element times first element is 1. Second element times second element is 4. And this is a 5. And this is not equal to that. Because this is BA. And in BA, first value is a 5. But in AB, first value is a 1. So that's how I would say it. So on my exam paper, I would say something like this. Not equal to 1. Right here. This value is not equal to 5. To 1 or something like this. That's a 5 not equal to 1 right here. And therefore, they are not commutative. The value different. In this case, so I can say therefore AB not equal to BA. Therefore, AB is not equal to BA. But the first value in this one is 5, first value in this one is 1. That's why. So find the inverse of A. So this A again, let's write out this one. 1, 1, 2, 3. Right down here. A is 1, 1, 2, 3. So I have it wrong. Yeah, 1, 1, 2, 3. That is A. All right, A to the minus 1 now. Let's do this part in purple. So A to the minus 1, remember, is 1 over the determinant of A times the adjoint of A, which is equal to, what's the determinant? This product minus this product. This product is 3 minus this product is 2. Multiply that by the adjoint from this matrix, or we form the adjoint. Interchange the elements on that first diagonal, interchange them, 3, 1. Leave these two other elements where they are, change the sign, -1, -2. All right, this under here really is just a 1, 3 minus 2 is 1. So the answer therefore is just this matrix. 3 minus 1 minus 2, 1. That's it. Shift this value over. All right, interchange those two, leave out where they are, change the sign. This under here just work out to a 1, 3 minus 2. So I don't change this thing. This thing comes back and change. That's the inverse matrix. Next part now says, this matrix, calculate value of x is the matrix modulus is 0. So it means that if the modulus is 0, the determinant, this is the determinant equals 0. Means that this product is equal to this product. The two diagonal products equal. Right? I can say determinant equals 0. When that happens, the two diagonals equal. So it becomes 3 times 2x becomes equal to 9 times 2. 3 times 2 becomes 9 times 2. All right? So this is really 6x equals 18. And so x equals 3. Done. Next part says, portion vector R, S, and T relative to origin O are these. So this one is O R, this one is O T, this one is O S. No, this one is O S. Let me write them out. Let's write them out. I don't want to take anything for granted. So the OR matrix is the first one. -3, 4. The second one is S. The OS matrix is 1, 1. And the last one is OT. And the OT matrix is 5, -2. Already know. The modulus of the first one. Modulus. Modulus is the square root of the first value squared and the second value squared. That's -3 squared. I'll put negative on it by squaring it. Plus 4 squared. Which works out to be 5. That works out to be 5. All right. Next part says expression for RS and ST. Let's do it. RS is OS minus OR. O times the last minus O times the first. The OS is this one, 1, 1. Minus the OR is this one, minus 3, 4. Therefore, now, equals 1 minus a negative 2, because 1 plus 3 is 4. 1 minus 4 is negative 3. They want ST. ST is OT minus OS. O times the last minus O times the first. The OT is 5 negative 2 minus the OS is 1, 1 again. Equals 5 minus 1 is 4. Minus 2 and minus 1 is negative 3. So you say two vectors are equal and two vectors are equal. Alright. It says using results from the combined using the results of combined vectors, justify that RS is prior to RT and that RST is a straight line. So we have the two vectors. We have RS is equal to, so them equal, RS equal ST, right? Them equal, RS equals ST. So RS equals ST. Two things that mean here. But them equal, they're actually equal vectors, you know. These are equal vectors. Them equal, it means that they're parallel and go in the same direction and go the same length. All right, so same direction. Them equal because they have the same direction and same length. Because them equal vectors, so they will have the same direction, same length. So they're also parallel. Once them equal, they are parallel. So they are parallel vectors. But also have a common point S. So one, they are parallel vectors. Two, we have a common point. Common point S. Once you have those two conditions, parallel vectors with a common point, the points are collinear. But then someone show justify that they are parallel. Yeah, we said it here. And because of a common point, they are also collinear. So therefore, RS is parallel to ST and the points are collinear. RST is a straight line. Done. End of this test. It will cost for 1 hour. What time we start? 11, 12, 1. It don't really take long. 3 hours. And we started after 11. But because I'm lazy today, I'm not going to work. So I'm going to make this up now again, please. To avoid this, you need to do the work first. So we'll do another paper tomorrow. People that are sent in the group. We need to finish it this evening before tomorrow, if we never did before. I want to join online tomorrow evening. And the students online coming in the classroom tomorrow. We're doing another paper tomorrow. All right? Wednesday, we're getting back to the regular teaching. I do a one topic also again. We have a couple of topics left to do. Race of change. We should have a geometry set. and the ruler, right? The body needs a long ruler and a geometry set. We're gonna do some gradient of curves and stuff like that. All right, so we'll have a couple of things to do. Do those on Wednesdays. Saturday's mock exam, as you know. All right, 2 papers on the weekend again. Working them out Sunday next week and Monday, as usual. When on Easter Monday, and something, forget about all of that, right? None of that. We're working every day. All right, cool. Or at least part of the day. You're at online, but the same thing goes for you.
Yes, sir.
All right? All right, good. Bye, everybody. See you online tomorrow. You inside here. Online people, see you in the class tomorrow. Bye. I'm going to send the recording to the group. Bye-bye.
Bye,
All
sir.
right, cool. All right, bye-bye.